Okay, welcome to day 4 notes. We're going to solve equations using, first we're going to do it without a calculator because we're going to manipulate them and we should be able to write things without a calculator. So the first problem I see, oh, okay, I don't like this 36 up front. And I have 1/3 x over 5 equals 1 over 9. And then I decide that, let me rewrite it with the same base. So I'm going to keep my 1/3 x over 5. So I have to think about 1/9 is really 1/3 squared. Well, now I have the same base, so I can cancel out those bases. I have x over 5 is equal to 2, and if I multiply by 5, I get x is equal to 10. Same thing for this next problem. Divide by 2, I get 5 to the x over 4 is equal to 125. I use the same base idea. This becomes 5 to the third is equal to 5 to the x over 4. I can cancel out my same bases. I get x over 4 is equal to 3, and I can multiply both sides by 4. I get x equals 12. So I started off with two problems. The original problems in both of them were exponentials. Both of them were a times b to some exponent, and they were equal to a number, and I manipulate them so I did not have to use a calculator. So I'm doing the same process for part C. I divide it out by the 2, and I get 10 raised to that exponent is equal to 10, or 10 to the first. I have the same base now. Negative x over 3 is equal to 1. I can multiply by negative 3 times negative 3, and the negatives cancel. I get x is equal to negative 3. This next one, this is a log problem, and to solve a log problem, I need to curl it at some time. So there's nothing else going on in this problem, so I can just write a 10. I could just curl it. I get 10 to the 4th is equal to x, or x equals 1 followed by 4 zeros, or 10,000. So this is a log problem again, same idea as before. The first thing I'm going to do is go from the base to the other side. I got 4 raised to the negative 1 is equal to x minus 5. Equals x minus 5. This is really just 1/4. X minus 5, add the 5. 5 and 1/4, or 21 over 4, is equal to x. Now this one, we are adding logs. So we add logs, we have to multiply these quantities. ln of x minus 3 times x plus 4 is equal to, and this moves to the top here, ln of 2 to the third. And now I have basically like I had before, the same base idea. These have the same base. I can multiply this out. X squared plus 3x minus 18 is equal to 2 to the third is 8. Subtract the 8 over. I'm sorry, I made a mistake. Not even paying attention. This is 12. Subtract the 8 over. This is 20. And well, let me start again. You have to bear with me when I do these videos. I make mistakes. I thought that was a 6. I can't even read in my handwriting. This is a 4. X squared plus x minus 12 is equal to 8. X squared plus x minus 20 is equal to 0. X minus 4, x plus 5 is equal to 0. X equals 4, and x equals negative 5. That is extraneous. That cannot work in the original problem. These problems are going to work out algebraically, but at the end I'm going to use the calculator to get a decimal approximation for my result. So when I see this problem, I could take the log of both sides, and this x moves up front, so x times the log of 1.06 is equal to log of 4.1. I could divide by the log of 1.06. X equals log of 4.1 over the log of 1.06, which is about 24.215. So as you can see, I did it on the calculator. I typed it in, but instead of using log, the common log, I could use ln. And I get the same result because log is base 10 and ln is base e, so I'm using the same base. I'm using base 10 here, base 10 here, base e here, base e here. I'm going to get the same thing. And you do have this special key on your calculator, math, up to letter A here, where you can choose the base. So it would be base 1.06 of 4.1. And we get the same result either way. So as you can see, I did it where the log of 4.1 over log of 1.06 is all equal to the same thing. Next problem, first thing I'm going to do is divide by 50. And I get this. And I have an e here. And what gets rid of e? The natural log. The natural log. These two cancel, and I have a 0.035x is equal to the natural log of 4 divided by 0.035. I get x equals ln of 4 over 0.035, which turns out to be a little bit less than 40. Okay, for this example, again, I have to isolate the exponential, which is the e raised to the negative x. Subtract my 3. Divide by negative 2, and I have e to the negative x is equal to 5. To get rid of the e, I have to do natural log of both sides. And to get rid of the negative, I kind of divide by negative 1, so I have x is the negative of natural log of 5, which is that decimal. Need to isolate by subtracting the 4. Need to get rid of the 3. It's okay, just leave it as a fraction. The base on ln is e, so I'm going to curl it. E to the 1/3 is equal to x minus 3. So I bring the 3 over, and I get the cube root of x to the 1/3 plus 3, which is about this number when I put this into the calculator. So I can do this two ways. Probably the easiest way is just curl this by making base 10. 10 to the 6 is equal to x squared, or x squared is equal to 1 million. And now I just take the square root of it. So x is equal to plus or minus 1,000. Why could it be negative? Well, remember, the first thing I'm doing in this problem is squaring it. So it works out. Even though x is a negative value, I'm squaring it first, so it could be negative 1,000. I'm going to do the same process in this next problem. This is base e. I'm going to curl it. I get e squared is equal to x to the 4th. I'm going to take the 4th root of it. I get x is equal to plus or minus the 4th root of this and that. I'm going to rewrite it as x to the 1/2, where x equals plus or minus the square root of x, square root of e, and that's about this number. Remember, when I do this, it would be e to the 2 over 4 power over root, and that's how I get this guy here. Okay, the last two problems, I'm going to have to manipulate this one a little bit. I don't like this fraction here. I could bring it over, but I'd just rather get rid of it. it becomes ln of x plus 3 minus 2 times the ln of x, and 2 times 0 is 0. And this moves up, so I get ln of x plus 3 minus ln of x squared is equal to 0. I'm subtracting, so I can divide. Ln of x plus 3 over x squared is equal to 0. And I could curl this. E to the 0, which is equal to 1, is equal to x plus 3 over x squared. I multiply by x squared. X squared equals x plus 3. Only way I can solve this problem is bring it over. And now I have to make a choice. And guess what? I cannot factor this. So I have to use the quadratic formula. So 1, negative 3, x equals 1 plus or minus negative 1 squared minus 4 times 1 times negative 3 over 2 times 1. I get x equals 1 plus or minus, well, let's see, 1 plus 12. I get the square root of 13 over 2. You want to split that into two results. X equals 1 plus the square root of 13 over 2, and 1 minus the square root of 13 over 2. But this is a negative number, so it's extraneous. Doesn't work. That's the solution. You want to write it as a decimal? I think it's about 2.303. Being that I set it up that it wasn't factorable, it was a much more difficult problem. I don't think I'll ever do that on a quiz or a test. In this last one, I'm going to use a substitution trick. I'm going to sub in w for e to the x and w squared for e to the 2x. So it becomes 3w squared plus 5w. I'm going to subtract the 2 over, and now I can factor this. Plus 2 minus 1, give me my positive 5 in the middle. And when I solve these, I get these two solutions, but I'm not really solving for w. I'm solving for x. Remember, w was e to the x. So I really have e to the x equals 1/3, and e to the x is equal to negative 2. And, well, we should know that I cannot raise something to a power and get a negative. But when I do this, this is impossible. Cannot do the log of negative 2, but I'm going to do it over here. And I get x is equal to the natural log of 1/3, which is about negative 1.099. It's a little substitution trick. Okay. Thank you for watching this video. Please ask questions during class.